Hello, electronics gurus. Here we have the infamous DJM 2000 Nexus from Pioneer. I really love this mixer. I've got it secondhand on eBay. As you can imagine, it has a fault. All of the inputs, all of the outputs do work. Of course, it didn't come in this condition though. It was never been opened. It had just a single genuine fault, and the fault is that when you turn it on, all of the inputs, all of the outputs work, all of the controls work, but as you can see, none of the lights work. None of the lights for the switches work. And I've been working on it for quite some time. Apparently, there is two MCUs which control the lighting and the state of all of the buttons and knobs. The two chips are called UCOM A and UCOM B. I swapped to UCOM B. I was so impressed to find out that basically you can order components, even MCUs pre-programmed from Pioneer. Such a fantastic service really from Pioneer. I was so surprised. Very nice service manuals on the web as well. But that didn't solve the problem. And I've spent already maybe 20 hours so far on this mixer, checking everything, and it seems like I can't make it work as it should. Now I want to demonstrate you something that is very interesting. This mixer have of course a service mode where you can test all of the lights and all of the inputs, outputs, and so on, and I will show you in a sec. There we go, in the service menu where we can go to different functionality of the mixer, and here it says everything's okay, blah 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 blah, and here all lights should be on, but the only light that turns on is this one, which is also called in the service menu a standby light. Now this standby light has a different control circuitry, which is on the main board rather than being on the board of the side of all of the potentiometers, where this UCOM B, which is a Renaissance MCU jobby. So yes, this button works. Now the funny story is, if I keep on scrolling to the menus, as you can see, what I can do is turn on the lights. And most of them work. Now, as you can see also, we have this flicker here, and we've got it on a few places. As you can see, if I keep on scrolling, this is the test for the for all of the sliders and so on. They do work, and they do work correctly, but the representation is wrong. Here, in terms of functionality, these all of the faders will work correctly when you play music, and all of the EQs and color effects will work correctly. But this is the representation. I've been looking through different serial communications and so on. I could not see a failure really anywhere. I have the feeling that there might be some issues with the memory somewhere, with EEPROM, with some of the flash memories, but I can't be sure in that. In the next section, I will show you also a visual representation on my little scope, so you can see the communication between UCOM A and UCOM B, where UCOM A sends a request and UCOM B gives all of the information back, which is always correct. But you can also see, after you press a button and so on, the UCOM A does react accordingly, aka it sends information about the state that every single light should be on the mixer. So there we go. And there we go. At the channel 2, where you can see the blue line, every time when I press a button, you can see this is the command which tells the UCOM B, please turn the light on the corresponding button. And in this case, ta-da, it does works. It does works. Now you'll say, well, what if you turn it on in a normal mode? So we switch it off, switch it on back into normal mode. You have some initialization here, and here you can see again, this is the first packet of data which stands in front of the second packet of data. The first packet of data is acknowledgement from UCOM B. Okay, I read your data, bro, I got you. And the second packet is where the UCOM B sends status of every single knob and every single button, where it says, let's say right now, channel 1, the low frequency potentiometer is out, and it will send the information, and it's correct, and that will reflect all of the digital sound processing, so you can hear the change in the sound on that very same channel. Now, as the mixer is in normal mode here, as you can see, this first portion, this also holds the information about the first cue. So when I press a cue button here, and I press it once, and you see nothing happens, but the data, the command data does change. So I'll press it once, I'll press it second time, now it's on, and as you can see, normally you just press once, and once you press a cue button, it should stay on. So this packet is correct, and as it should be. So I spent too much time on this project, so the next thing I'm thinking of, maybe I should just hijack all of the lights, read the SPI data from UCOM A, and just mimic what it's supposed to do. So I will read this packet, which, funny enough, the first packet is 36 bytes in total, and the next one is 100 and something, which makes around 150 bytes for all of the data for every single knob, position, and how every single light should be going on. So here we have my good old trusty STM32 for just looking at the data and the entire packets and just see which lights corresponds to which bit. So every single bit in this first packet of 36 bytes will correspond to a different light. Then the control of the lights, how am I gonna do that, you're asking me? Well, what I will do is I will just hijack all of the pins which are for the lights. The lights is arranged, as you can imagine, you don't have a single pin for Yay! You don't have a single pin for every single light. What Pioneer did, and it's a common practice. You have light grids and light segments where a combination of two is going to deliver a control for a certain light. So the combination of all of the segments and grids can point out to a specific light. You say, well, you don't really need that, how many buttons and lights you have, but have in mind the EQ lights are also controlled the very same way. I don't mean the EQ lights, I mean these thingy things which show you how much you're torturing your sound system, really. So unfortunately, I'm 6 GPIO pins short to have all of the light segments and all of the light grids controlled. But I'm getting a STM today, just another Nucleo board with a bigger pin array with more pins to control, and then I will try to hijack the SPI. Why you say hijack? I'm saying hijack because I'm not going to give outputs. So I'm not going to tell to the UCOM A the actual status of all of the knobs and buttons. I will leave that for the original onboard MCU, which is doing the job perfectly and everything is working there, and see where it goes. I really would love, I will probably just make a small tiny little board if this concept really works well. I will make a tiny little board with the MCU with more pinouts just to suit the purpose, with nice mounting points and so on. But unfortunately, what I found out is that I can't fix the fault, guys. I'm so frustrated by it. But it could be everything here. Maybe there is problems with some of the FPGAs. There might be a problem with some data rail, which is making the rest of the system suffers and making delays, and you might be having somewhere inconsistencies in the packages. It could be, you know what, maybe it could be even like somebody just swapped all of the boards and left the main board, the original board, or maybe just swapped the main board only, and there is differences in the firmware and the handshakes and so on and so forth. But just to show you how wild and how much data you have here, this is a tiny little portion of the data. That's just the first few bytes, and here you can clearly see this first portion contains the command, and as you can see, here's the data from the MCUA. It contains I want to be about the light statuses, which one should be on and off, and the second one is for the actual status of all of the knobs and buttons, which is way bigger. One thing that you can notice though is that we have a repetitive change in data, which might be due to stuff I really don't know about because this is not an open source project. But if you have any ideas what's going on, please let me know. It's very interesting also, this SPI communication. Here you can see this is the CS coming from UCOM A, which is the main board, to the slave, and then here you have it again for the second package. But there is one more line which is called int, I guess stands for interrupt, which cosigns with this one, but it's initialized from the slave, from the UCOM B. So the UCOM B says, hello, I want to talk to you, please, I have these knob positions and stuff, and then UCOM A again toggles the CS and gives the clock. This purple thingy here is the clock, and we give this massive rich data for the positionings. Unfortunately, here I'm with this scope from work, and this scope is so quirky. It's not what I'm used to, so my triggering is not very perfect, and I can't show you the stuff going on into this data, into this second packet. But I can assure you it's correct, and there is no, the data is very, very consistent. This thing, very dodgy, very dodgy. Also, do we need 36 bytes? Is this some kind of a dual retriggering where you have some of the rest of the system, maybe an FPGA says, give me this info, then give me this info again, just before the info has been sent, or some synchronization. There is wild, also very wild, fast clocks being shared on long traces, like you have these 20 megahertz and 25 megahertz, which have been shared through long traces, including flex cables and so on. Kind of dodgy, which also might be fitting the problems with the, as you can see, the MIDI buttons flickering, and all of the representation of the parameters in safe mode, again flickering and showing crazy values. I don't know, but this is it so far, guys. If you have any suggestions, please be welcome, and if you want a video about the quirks, which are many on this scope, please just let me know. Thank you.